Hey there, welcome back to the channel. So let's just get right into it. In the previous video, we refactored the malloc package, like our malloc, and here now we will be changing some stuff for the myFree function. So here we check if the left block is free and if right block is free. If both of them are free, so if left free and then right free, why is this? It is for coalescing. So here we'll call, let's say, coalescing RL will send in free pointer and we'll also send a pointer. Yeah, like that. Yeah, so our previous function lies over here. So this is the current working coalescing RL, but since we changed up our design, we'll also be doing this. We'll also be changing it. So block, header, pointer, pointer to a pointer. So free pointer, basically get a pointer to it. Now to get the size of it, so we'll cast that into pointer, right? But pointer is for space, right? So we'll move behind by header and then cast it. Yeah. So so let's say block header. Yeah. Let's call it block itself. Casting into block header, char pointer, our pointer, move behind by header itself. Boom. Yep, done. To get to the sorry, to get to the right block, let's get to the left block first. So get to the left block, we should first get its size. So to get to the left block, well, we'll only get to its footer. So left block is equal to block header, char pointer, pointer. We move behind by header, and then we move behind by footer as well. Yeah, and then we cast it. And to get to the block header of right block, we go block header pointer, char pointer, pointer plus. We move ahead by this type over here. Yeah. So we have to move ahead. We are at this, so we have to move ahead by block size. Should I do it like this? No, it's fine. My bad. So block, yes, size, and then we also move ahead by footer. Yeah. We are over here, move by block size and then footer, and then we have uh, the header to it. Yeah, cool. So the size, the total new size will be equal to block size plus um, block size plus left block size plus right block size. Cool. And then we will also have yeah, wait, where's my marker? Okay, I have a whiteboard with me, but I've left my marker on the table. Just give me a minute. I'm back. So, okay, let's just. So, whiteboard. It's just, If you visualize, it's easy for us to understand. So let me just think about it. So we have this header, footer, we have this block, and then we have this block. Yep, cool. And we will have at our disposal two blocks, sorry, two headers and two footers. Sorry. Oh, I'm so sorry. I think that might have like destroyed your ears. So at our disposal, we have two headers and two footers. Cool. I should have just gone with two times headers plus footers. But okay, that's fine. This is easy to read. Okay, so we have total size. That's cool. Now we have to yeah, left block, right block. Yeah. So now I have to make it so like I have to skip the block. So let's write that function. So the skip block function it's a cool function. No, decent function. So left block, we send in three pointer. Okay, left block. Hmm, we should be sending in address. Oh no, 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 we already have it. Sorry. So skip block, right block, three pointer. Yeah, let's get let's change our skip block function. So we are over here. Yep, cool. So this is yeah. Let's do it. So void skip block takes in a void pointer and wait, it takes in a void pointer and it takes a pointer. Yeah, cool. Which is header. Oh, it's a header block. Right. Yeah, I need like I will need a header for this left block. Okay. Yeah, let's get that. So left block header footer. Left block is equal to, so we are at left block footer. Yeah, cool. We are at left block footer, and then we move behind by what you can say by header that is necessary, and also by left block footer size. Yep. So I guess this is correct. Yep. Yep. Correct. So we'll send in left block, right block. That's cool. So header block. Yeah, this is three pointer. And we are sending in pointers, but they are block headers. Sorry. So we get a pointer, and to change its value. Yep, cool. What was the previous function? Yeah, if previous is equal to null, then we just move it. Yeah, cool. I get it. So I have to first check. So if pointers previous is equal to null, then I have to change the value of the pointer. So free pointer die. Hmm. Free pointer is equal to current next. Yeah, yeah, cool, cool, cool. Okay, so we go over here somewhere. Go this in RL, skip lock, yeah, here, yeah. So we dereference that, and then we see it should point to pointer next. Yeah, if there is nothing to be previous, yeah, cool, cool, cool. So now also I have to check if previous pointer is not equal to null. If previous pointer is equal to null, then nothing. And wait, why did I add else if? And if I have to check like suddenly next block is not equal to null. Yep, cool, cool, got it. Else if pointer previous is not equal to null. Yep, then I have to if previous pointer is not equal to null, so that means like there is a next block and then we have to skip it. So I have to make it so like let's call it block itself, you know. Why call it pointer? Yeah. So blocks, the previous blocks next pointer should now point to blocks next itself. Cool. Yep, that was it. And I have to check if next block is equal to null, or should, it's not equal to null. So I have to change its previous value. So next block's previous value should now be equal to block's previous value. Cool. Next block's previous value. The previous block's next value should be next, and next block's previous value should be block's previous. Yep, cool. So this is cool. So this is skip block. It might work maybe. So yeah, let's comment this out. So okay, cool. So these functions are working. Let's head to like coalescing RL. Sorry. Yep, let's go ahead. So my function, so it calls skip block over here. Yeah, we were over here somewhere. Where were we? Oh, I forgot. Where were we? Yeah, yeah. So skip block skips this. Yup. And then I have to change like the size values. Yeah. So now the size values should be the equivalent of merging them, which is X, Y, Z, plus two headers and plus two footers, right? I should also do mem set, but I'll do it later on. So skip block RL. So now I have to change the values for it. Okay. Right block footer. Yeah, let's also get that. So right blocks. We are at right block currently, and then we move ahead by right block size. We're at right block, so we move ahead by right block size. First of all, we move ahead by header, and then right block size, and then we add the footer. We cast it, so that's cool. So now we'll change the values, which is so yeah, we're coalescing this, right? Hmm. Cool. So, return, not return. So block, wait, why am I blank right now? Sometimes I just get blank and I can't think of anything, and my brain goes in a continuous loop of like making fun of me and not remembering stuff. Okay, what was I trying to do? It's okay. So skip block. Let's. Okay, yeah. I had to change the values here. Cool. So I have the total new size over here. Two headers and two footers were eaten. Two headers, yep, and two footers were eaten. Yeah. So let's change the values at left block. So left block size value should now be total new size. That's cool. And then right block footer size value should now be total new size again. So that's cool. So this is cool. So now I've changed these values. I should set mem set, but I'm only. Would that be dangerous? Sorry. So right block footer, this is cool. We set the values, hmm, and then we return the block pointer, which is the right block. Yeah, yeah. Let's cast that. So block header pointer, new block is will be our right block itself. Sorry, it will be our left block. So this will be left block, and then we return new block, and this should be header block. Cool. So we have working coalescing RL. So let's comment this out. Let's make a coalescing L. So this should be header block pointer coalescing L, void pointer to pointer, not void, header block pointer, the pointer. Wait, which one is true? Header block or block header? Ah, it's header block. Wait, I should use find and replace, right? Okay, it's done. Yeah, now which one is block footer? Yep, cool. I am in term. Sorry. Yeah, yeah, okay. So this is yeah, header block, pointer, it's called a block, boom, boom, boom. Yeah, we call it block, right? Yeah, there. Pointer. Oh my God, it's not wide. What are you doing? Yeah, it's header block. Let's also change that in my free function. So coalescing RL sensing pointer. Yeah. Oh, it needs to be a void pointer. I'm dumb. I'm dumb. I'm so dumb. Yeah, skip block has sent a void pointer, so that's cool. Skip block is sent what? Yeah, okay, okay. Let me think of it. So left free block and right free block are sent like void pointers, which is I'm going to let's remove this altogether. There's no point in keeping the code that we don't need anymore, right? Yeah, okay, cool. So yeah, cool. This is not working. So right free block is in void pointer, so that's cool. And then we have inside coalescing RLs. So skip block calls left block and free pointer. Free pointer is header block pointer to pointer, and a left block is header block. Yeah, header block pointer to pointer and a header block pointer and header block pointer to pointer. So that's cool. No, cool, 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 cool. Okay, cool. Let's also make this. Yeah, 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 this is fine. So okay, this is cool. So coalescing oral, we also receive a pointer and then header block pointer, but it is coalescing function. Coalescing function is supposed to call void pointer. So coalescing functions are supposed to call void pointer. So this is supposed to be a void pointer. So we get void pointer, move beyond by header, and then we get casted. Okay, cool, cool, cool. Okay, fine. This will also be a void pointer. So the same thing. Am I audible? Yeah, cool. So, what was I thinking? Yeah, the same function that are present over here. Let's copy this, paste it. Let's remove what we don't need. So for left block, we will need R block. We will need R footer. So, so footer block footer is equal to so footer block char pointer R pointer plus block size. So that's cool. Then we cast it into block footer. That's cool. Instead of calling this left block footer, shouldn't it be like left footer? No, this is fine. Okay. So yeah, we have block footer. We also need left block footer. So that's cool. We don't need anything related to right block. So our total new size will be eating up one header and one footer. Yeah. So block size plus left block size plus a single header plus a single footer. So that's cool. So block size plus left block size plus header plus footer. That's cool. So okay. So now we have to skip block. For skipping the block, we give it the left block and then we give it three pointer. So that's cool. And then we change the values. So to change the values, we need left block. So left block size is equal to total new size, and then we need R blocks footer is equal to total new size. This is supposed to be size. Just give me a minute. Hey there, I'm back. So let's get right into it. So block footer size is total new size. So this is cool. Sorry. So yeah, we changed the values for this. Yeah, and the new block uh, header block, new block will start from our current, like the left block, right? Left block will be the new one, and we'll just return this. Return new block. Cool. Yeah. So coalescing RL. So this is done. This is done. We'll remove the previous one. Boom. Now let's write coalescing R. Just give me Hey there, I'm back. So, okay. So, coalescing R, we do the same thing. We copy this. So, we are at the pointer. We get cast the block. Yeah, this is fine. Let's copy this. So, boom, boom, boom. So, block. So, here we don't need anything related to the left block. Yeah, we need the block. We do need the right block and the right block footer. So, this is cool. Okay, so this is cool. So the total new size will be block size plus right block size plus a single header plus a single footer, and yep, this is fine. And then we'll be asking to skip the block, so skip block right block and send in, yeah, we'll send in free pointer. Cool. And then change the size values for it. So size values needs to be changed at block. So block size is equal to total new size, and then we'll change the size value at the end of the new block, which is the footer of a right block. So right block footer is equal to right block footer is right block footer size is equal to total size, and then we just do header block new block. New block is our current block itself, because of block starts from there, and then we just return the new block. So that's cool. So we don't need this anymore. Yep. And here, else if, yeah, let's copy this. So coalescing. Yep. Let's copy this. So now these functions, the new block is a footer. Sorry, it's a header. So header block pointer, which is currently um, header block pointer. What did I do for the my free? That was pointing, and then they change its value. Ooh, we get this, so we have to move behind by uh, what do you call it? We have to move behind by header. Yep. So we get pointer by default, move behind by header. So it's cool. But if its value changes, it's fine. If it changes, it changes. I'm audible? Yep, I am. So how many minutes in? 35 minutes in. That's cool. So coalescing RL, coalescing L, coalescing R, so this is fine. And then when we get to the new blocks, we have to change its previous and next pointers. So that's cool. I mean, we have to change, like, we have to make it so that it is the like part of the new free list. So yeah, so let's do it. So what was it? Yeah. So new blocks. So the new block that we have. So next pointer of the current block. Yeah, it should be the new full pointer. Yeah, yeah, cool, cool, cool. So the new block New blocks. Next pointer will now be free pointer itself, and then free pointer will be new block itself. Cool, cool, cool. And the previous layer, the previous pointer. So the new blocks previous pointer is now pointing to null. Cool. Sorry. Now I have to check like if the next block, yeah. So if free pointer was okay, but okay. If next block is not equal to null, so we have to change its previous value. So next block previous value should now be on new block. So this is cool. Sorry. And it's a void function, so we don't need to do anything. So this is cool. So this is working, I guess. So okay, cool. So my free coalescing R, coalescing L, coalescing RL, skip block, right block, and this malloc. So there will be some errors, but we'll check them out like later on. For now, we don't have any deeper code over here, right? Yeah, let's just comment this out and let's take a look at it if it compiles. So mdriver dash f short traces 0. I think there might be some compilation error. Yep, as I expected. So flock file, block size, user fund declared block size. Why is that? Allocated 299. Let's look at 299. So block size is equal to free block size. Oh yeah, this is supposed to be size D. We had 13 errors. Now it is 9 errors. Cool. Uh, expected expression. So use of undeclared identifier block footer. Oh yeah, yeah. Sorry, footer block, footer block. Yeah, I think it's okay. 6 errors. Okay. So redefinition of block with a different type header block, aka struct header block pointer versus void pointer. Okay. 395. So we have block. Oh yeah, this is supposed to be pointer itself. coalescing L, coalescing RL, R is fine, L is fine, and this is fine. Yep. 6 zeros is now, boom, it works. That's cool. Oh, block size. Come on, why is it not working? Did I mess up something? Did I end up, did I end up on a, is it a while loop? Is there a while? Yeah, also, let's also do this. Yeah, I'm stuck inside a while loop, and why is that? So while current is not equal to null, I am, if current size, there is no terminator. While current is not equal to null, so current is never equal to null, current is current. Next, so hit a block, current is three pointer. I think I know why. Yep, I think I know why. So when we are coalescing stuff over here, we're not changing the values of it like we used to do. So let's change the values for that. But we are doing it. Sorry. Okay. Let's try to, you know, sorry, my light is messing up. Let's find a free function that works. Not a free function, but a sleep function. Sleep function C. There must be a time library, right? My internet speed sucks. So. Yeah, let's see. So fun. Sleep function C. Come on. Why did you go to sleep? We are already 44 minutes in. Come on, work. Why is it not working? Why is it not working? It should have worked. Why is it not working? The internet has switched. Oh, okay. Yeah, okay. So we indeed have just give me a minute. This is okay. I'll check this out later. Okay, so we have a sleep function, pulse execution for pulse execution for 5 seconds, pulse execution for 500 milliseconds. You sleep, yeah. Okay, so this has a sleep function. GG. Rotating, please don't go for let's say current block is current size and then sleep for 5 seconds. Yeah, okay. Okay, cost of current block is 2073. Oh yeah, we didn't handle like the even numbers. So current 2073. Hmm, strange. Strange. Why is it 2073 again and again? So traverse functions. So yeah, over here. Yeah. So printf allocating a size of a block of size line size. Yeah, block font is 2073. We should have yeah. Let's change the value over here. Go in the coalescing functions. Yeah. In the coalescing functions, we did not like consider like the size. So yeah. So block size we have. So block size -1. Why? Because for allocated block, it is going to be like allocated and it is going to be +1. It will be odd. Did I use block size anywhere? Oh my god, this is tripping. Just give me a minute. Let's just okay, let's get back to it. So, where were we? Yeah, so I think we should set for coalescent functions like block size beforehand. Yeah, let's set it beforehand. So size the block size is equal to block size. Right, cool. Sorry. So this is block size. Yeah, yep, block size. Boom, boom, boom. Yep, link, paste. So block size will be block pointing to size, block pointing to just this. Okay. Oh yeah, here we need the value to change. Cool. So did I mess up somewhere else also? No, only. Yeah, this is fine. Block size. This is fine, right? Block size value. We are changing to the new size. This is fine. Block size. This is fine. This is fine. This is fine. Sorry. So for allocate block, this is done. And then yeah, let's try this. Okay, so this is pretty much instant for 2040 because we are calling them as PRK. Uh, doing a block of size. So what should be the size? It should be new block. Messing up somewhere with 2041. Okay, so looking to free a block of 2040. Yeah, this is fine. This is fine. It's acting up again. Just give me a minute. What are you doing? Okay, why are we calling 2073 again and again then? Looking for a block of size 48. And let's go inside the while loop. Yeah, block found 2073. It constantly finds a block of 2073. Hmm, 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 hmm. Let's try to, yeah. Let's change these functions, should we? Right? So void pointer, not point pointer, so construct the block so we get a pointer. Yeah. So we get a header block pointer, yeah. So header block pointers, construct three block. We get a size to size. Sorry, size t, align size is equal to align size, cool, size t, total space will be align size plus header plus footer block is equal to none sbrk total space. This is fine. and then block header, right? Yeah, I have to change values for it. Cool. So let's cast that into header block. So header block pointer header is equal to casting header block pointer at the start itself. So block and footer block footer is equal to casting into footer block cal pointer block. So block and then we move ahead by total not total space but align size. Yeah. So I'm at this place. I'm at block. So we move ahead by a header and then we move ahead by align size and then we directly at the start of the footer. So cool. So now we will change the values for it. So header size is equal to line size and footer size is equal to line size again. And then we'll return the start. What should we return? The header. Cool. So we don't need this function anymore. Oh my god. This is going to give me a seizure. We have to change. Oh my. I can't even turn that light off because like, I don't have. I have to select set somewhere else. Okay, 58 minutes in. Let's get this done. So void change previous and next values. So first of all, we'll get header block, R block, and header block. The next one, yeah, let's call it change itself. Change next, and then header block, change previous. Cool, cool, cool. So now we will write, yeah, to change the values, right? Yeah, so block next is equal to change next, but I will check. Sorry, change next and blocks previous is equal to change previous. Wow, great. Let's comment this out for now and then void traversing. We get a header block pointer, pointer, and then we just move it. So current is equal to a copy of pointer, and while current is not equal to null, we just move ahead. So printer blocks edu boom boom. Oh, no, messed up. And current size from current is equal to current dash next. and nothing over here. Yep, that is the function. Now I'll remove this, right? No, don't need this anymore. So edit block, edit block, edit block. We given the block one, block two, and block null. So this is fine. Cool, cool. And free pointer, why do we need this? Let's give it block one directly. I hope this should work. So now we will, what should we do? Yeah, the debug code that we commented out. Yeah, let's try. So, configuring types of construct free block takes in size, size values, and we are sending in, yeah, we did not change anything over here. Edit block, edit block, edit block. Yeah, yes, this is fine. Void is not a current member references made. Type void is not a structural union. Type void. Why is that? Member reference base type current. These are the traversing, right? 162. Oh yeah, yeah. 1024. Yeah, this works. So blocks are getting recognized. I didn't get the testing complete thing. Yeah. So yeah, testing complete. Nice. So testing complete. Let's also do one more thing. Yep, this one's done. Looking for a block of size 2040, 2040. Again, clean the block of 2040. Looking for a block of size 48. Why do we get 2073 over here? Why is that? Why is it? What is it something related to 2072? It's 32. Am I missing something? So okay. So first, looking for a block. Let's open short traces. So short traces is the first one. Yeah, so this is allocate. These are the first two statements, and then we free one, which is 2040, and then we allocate 48. So that's what we see over here. Looking for a block of size 48. Okay. Yeah, let's do this. So header block. So traversing will look like this. So schedule points to something and size, and then we add print f new line afterwards. So how about this? Right, cool. Yeah, and then let's add at like every function, looking for a block of size this, and then boom, traversing three pointer. Mm, yeah, so being a block of size this before pre-list, traversing uh, free pointer after free list, traversing free pointer. So what does it look like? So 201 doesn't complete, looking for a block of size 2040, freeing a block of size 2040 before free days and after free days. So after free days, somewhere in the free days, we are 2073, something, somewhere it's 2073, somewhere inside the free function. Something is messed up. Most probably it is inside coalescing, so one of the coalescing functions. Um, yeah, let's add printf first. So printf rm, printf l, printf r, cool. Before free list, we are inside r and something messed up. Yeah, we go inside r, we get a block size, block size. I think I should learn GDB because then it will be easier for me to debug stuff. Yeah, it's 2040. That is fine. The total new size is block size. Hmm? The total new size that we have is just give me a minute. Okay, so the total new size that we have is so the block size. Oh yeah, I did not do this here. Here. Okay. So freeing a block 48 to create a block. Let's take a look what happened. So 2072 block size. So freeing a block of size 2040 allocate. Looking for a block of size 48, 2072. Why is 2072 here? Not sure. So block size. So we have block size over here. Block size is whatever. Let's also get like the right block size. And why is it inside? Oh, I get it. I get it. I get it. It is inside Rn because we have to also check that it is okay. Yeah, yeah, not just this. We have to also add a condition inside left free block in this. Then not only is it even, it should also be true, which will be the which will be the first condition. So that block size. Yeah, so one means it's allocated. Left block size. So let's add it over here itself. So size the left block size is equal to left block size, and if this size is at least true, if this size is true and it is 0, then oops, sorry, then we'll return true or else we'll return false. Cool. I'll add this over here. Also, I will add this statement over here. Yeah, okay. Right block size and replace with 0, true, replace with false, size t. Yep, cool. I guess now it should not be a problem. Okay, okay, so it's neither L, R, or whatever. So I guess it's working. So what we basically did was we did not just rely on uh like the free blocks, like the adjacent free blocks should not be like just simply even. It should also be real. It should not be like zero. Now that I think of it, hmm, that is really weak because some garbage value, if it gets picked up, we are done. Oh, this is weak. This is weak. Oh boy, this is weak. We need something strict. For now, it's fine, but okay. Sorry. Okay, freeing the block of size 2040 before free list and after free list. Yeah, yeah the value set. Yeah, let's add a else condition over here. New block size is equal to, I'll just reduce it. Nice, nice. Yeah, cool. This should do the trick. Yep. So block found 2040, another block found 2040, but we were not able to return it. Why? Did you not write the return function? Is that the reason? Segmentation fault. That's fine. That's fine. So we return over here, we are over here. Lol, 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 lol. So now we should see a block found. Come on, block found? Block found? Yep. Why did it take so much time? Block was found, and then we get the segment. We got the segmentation fault and 2040 in a single moment, right? So traverse failures did something. Something inside traverse failures is taking like a lot of time. It's okay. Okay, so printf if inside else. Yep, inside if. So we are changing free pointer. So the value at free pointer should now become current next. Why are we doing this? We can directly see like free pointer is now current next, right? We don't need to do all of this. Yeah, absolutely. We have to change like this. Where did it go? So free pointer. Yeah, we have to change. Indeed, yeah, we have to change it. Yeah. So current next. So if previous is equal to null, see free pointer is equal to free pointer next. About this, free pointer is equal to free pointer next. Is not structure union. Oh yeah, it's a pointer to pointer. Yeah, dereferenced. So we change free pointer. So the free pointer, block pointer. There should be current next. Something over here is not adding up. We are getting a segmentation fault, right? Wait, I did change that. Yeah, let's see. Okay, block farm segmentation error we got over here. Yeah, segment idiot. Yep, I got the segfault idiot inside if I did change the value over here. And then current next, if current next is not equal to new, if current next is not equal to none, if it's not equal to none, then current next Xbox this pointer should be none. Cool. I don't know why it's taking so much time. We are getting the block found lol. Let's remove this. Yeah, okay. So we are getting a block found lol lol lol, and then we get a segmentation fault over here. So block, let's say, so block size minus align size. Somewhere we are getting over here. Let's say we get seg fault. Ooh, binary search. Let's go. Dare you to print this. Let's see. Dare you to print this. Yep, it works. And now I dare you to print this. Yep. So something is missing over here. Let's do a dry run. So we get block size minus align size should be at least header plus footer. That's cool. So we get a total split, useful space, cool. Block size minus line size. Oh yeah, I messed up. 2040 and 48, and hence the total split. The useful space is like this. Okay, so the total split, so 2040 minus 48 gives us 1992, and then out of that, uh, 32 bytes is like taken. Why is that? Because our header has uh, just a minute. I'm back, so let's just get into it. So 1960. So yeah, our header block has a size T, which let's say it's 8, and then it has 8 again, and 8, which is 24, and then our footer is of 8, so that is 32, so that is cool. Cool, cool. So I understand where the 32 is from. Yeah. So allocated header, header block, and the free block right itself. Yeah, okay. Points to this, you get a header block. So allocated header is this, and then this is free block. We move ahead by header and align size. So we added allocated footer, so this is cool too. Allocated header size is aligned size. The next is null and the previous is also null. So this is fine. Allocated footer size is equal to align size, so this is fine too. Now the split header starts from allocated footer plus footer. Cool. Ah, sorry. Yeah, I think I missed this one. Come on, work. Okay, sec fault. So okay. So split header is header block allocated footer plus footer. So this is fine. And in the case of split footer, this is allocated header plus useful space. And this, then the split header size is useful space. Split header next is three pointer next. Okay. Split header previous is equal to null. Three pointer next. Okay, so yeah, I think we messed up over here. So free pointer is not equal to null. Yeah, I think we messed up over here. So split header's next value is actually free pointer's next. I should have said it is free pointer itself, right? Right. Yep, something crazy is happening. Okay, I get it. Mm, So what I'm thinking is like, okay, so we have split header. So now our split header, so like the new blocks next should become like the free pointer itself, right? And if free pointer is not equal to null, then yeah, also there's a free pointer. Also, I think we should change the free pointer itself. So free pointer is equal to split header. So if free pointer is not equal to null, then free pointer's previous should be split header, and free pointer is now split header. Cool. Wait, let me remove the 5 second thing. Yeah, I think I should add it. So 2040 not found, not found. 48. Yeah, yeah, let's stop there. So 2040, we don't find anything. Block not found. Cool. 2040, block not found. Freeing a block of 2040. Cool. Before free list, it's nothing. After free list, it is 2040 null. Looking for a block of size 48. This is because we are over here. Yep, cool. Block found 2040. Block found null. Split. Looking for a block of size 4072. So it is 1960 block found. 1960, but it should not be found. Block not found. Yeah, yeah. Cool. Freeing a block of size 4072. Freeing 3, which is this one. Cool. So 4072 must be added. So before free list 1960. L after free list 6040. 1960 plus 4072. 1960 plus 4072 plus 32. 1960 4072 and 32 also. 4 10 16 10 6064. Yep, cool. Good. Damn. Okay. So after failure 6040, that's cool. Looking for a block of size 4072, which is this one. We use the 6064 itself. Total split 19. Yeah, yeah. So 6064 4072. Total split 1992. Useful space 1960. And then freeing a block of size 2040. Freeing a block of size 47. Wait, let me draw it. How did this become like this much big? This should not be possible, right? Also, that is 6168. Let's run this one more time. Yes, let's clean the output so it is easy for us to read. So block found. Yeah, inside the traverse function. Yeah, let's not add this. This is stupid. So traverse function is nothing. So my malloc function is the first. Okay. So block not found. Yeah, yeah. Yeah, let's keep this. So block not found. Block found. Sorry. So CI boom. Block found. Yeah. Now this will be readable. And then yeah, let's keep this. Also, yeah, let's keep the RNs and yeah, freeing the block before free list. Yeah. Also in my malloc function, let's add that. So we are over here. So printf looking for a block of size this, traversing. Okay, traversing, and then let's add after traversing the pointer. Cool. Yep, this is fine. Let's take a look at this. So looking for a block of size 2040, block found. Yeah, so it ends over here. Yeah. So let's take a look at this. Let's also draw. So let me clean this up. 1 hour 43 minutes. This is going to be a very big video. This is going to be the biggest video. It won't be a hit necessarily, but that's fine. We do it for the thrill. Yeah, okay. Let me show you guys. No one's going to watch this, but it's fine. So this is visible. Bring this closer. Uh, should be here. This, yeah, this is okay. So first of all, let me write what all do we get. So first we have allocate 0 2040. I'm only writing the important ones. So allocate 1 2040. Should I write it there? Yeah, because we are not going to need it as much. So let me write in that corner. So allocate 0 2040. Allocate 1 2040. And then we have free one. So free one. Sorry. Allocate to 48, and then allocate 3 4072, then free 3, and then allocate 4 4072 again. Then we have free 0 free 2. So 0 1 2 3 are freed. Allocate 5 is 4072, free 4, and free 5. So okay, so we have this as our instructions. So let's draw a diagram. So this is our memory block. Okay. cool and all. So first we get allocate 2040. We allocate 2040 to it. Let's make it bigger. 0 2040. Then we have allocate 1 2040. So I will also write what I'm supposed to like get like as my output. First let me just visualize. So allocate 1 2040 again. Free 1. So free 1. Okay, cool. Allocate to 48. Yeah, let's allocate this over here itself. Yeah, allocate to 48. 48 has been allocated. Allocate 3 4072. And then we have free 3. So we have to free this, but it is nowhere near, right? It's not adjacent. Oh, it's not adjacent. So it should actually be it RL should not be called over here, right? Then why did it get called? Wait, something. Okay, RL should not be called over here. So if this is free, our list should be this. It should not be added. Why did we get the output then? So we get, sorry, so we get 2040, 2040, free list is 2040, then we are asked for 48. Oh, I get it. Sorry, my bad. I'm dumb. I'm so sorry. I'm so dumb. I'm so dumb. Yeah, okay. So, yeah. So when our first block is freed, so this was 2040 and it was freed. So now when we are asked for allocating 48, we just allocate some portion of it. So this was the one block. So we just split it. So this is 248, and this is the earlier one, which is not call, let's not call it one, but let's call it it will have a size of 1960, and it is free. Then we allocate 3, which is 4072, because we cannot give this space to that one, right? 4072 cannot be allocated over here. So we allocate over here, and then we are supposed to allocate, then we are supposed to free this one. What was it? 3407. So 34072. And now this is supposed to be freed, but then we find a left block which is free. So we merge them together, and this becomes a block of 6064 as we calculated earlier. Why 6064? Because 1960 plus 4072 plus 32 because of additional header and footer. So this is 4, this is 16, 10 carried, sorry, 1 carried, and then 6064. Yeah, easy. So now we have a bigger free block of 6064 sitting over here. That is cool. Sorry. So this is done, 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 this is done. Now allocate 4, 6072. We allocate from this space. So 6064 minus 4072 to 5. This will be 9, 16, 9, 9, 1. 1992, which is correct. So total speed is 1992, and the useful space is 32 removed from that, which is 1960. So cool. So this 6064 block is split again for this. There we have 4 as 4072, 4072, and what was it? Yeah, it was of size 4072 and it's allocated. And then we have the remaining part, which is 1960. And what is it? 1960, and yeah, it's freed. I am free. So this is done. So now we free 0. So 0 is freed. Cool. You are free, my boy. So this is also done. And then we free 2. So free 2 should call L now. And that is correct. Free 2 indeed calls L. Wait, wait. So this was 6064. Looking for a block of 4072. And then 6064 vanished. So now our block looks like 1960. So 1960 is the only block inside the free list. Cool. And then we see that the first block is freed, 2040, freeing a block of 2040. 6168 minus 60644, 104. It doesn't make any sense. Where did the 6168 block come from? How many minutes in? Yeah, okay, so we are 1 hour 55 minutes in. That's a lot. Okay, let me just take a break for a few minutes. Well, not a few minutes. I'm just looking like how like, the video which was published today at 7 p.m. is doing. I have to just check. Oh shit, mine is 9 minutes. Okay, it's terrible. Okay, sorry. So 1960. Where did the 6168 block come from? If we were to merge let's say this, and what if we were to merge these blocks? Where did the 6168 block come from? Is that a random occurrence or is it doing it again? Let's try. Sorry. Cool. 2040. Okay, looking for a block, process onto this. Oh, yeah, it's doing it again. We found 6168 again. Not cool, not cool, bro. Not cool. Where was it? Yeah, we found 6168 again. That's not cool. Where did the 6168 come from? Where did it come from? Where did it come from? Well, let's see. So 6168 apparently was merged from left. So it had an additional header and footer absorbed. So let's remove 32 from it and also remove 2040 from it. So we get like 6. Okay, so let me just do it simply. So 2072, 6168 minus 2072, 6040. This is 10. 4036? Really? Where did it come from? Wait, let me type with a calculator. Am I messing up maths? Simple maths. Come on. 6168 minus 32, which was eaten, minus 2040. Yeah, it is 4096. Yeah, I can't even do simple maths. 6168. Oh, wait. Why did I do this? Yeah, it's 4096. Oh, yeah, it was 16. I forgot. 4096. Which block had 4096? 4096. The difference is 96 minus 72 for 34, 24, sorry. Okay, I'm messing up something, but I don't think I can debug like on this video. It's already 2 hours in. I think this video is just like too long. So let's end this over here. So yeah, let's end this. So this was a okay video. We did a lot of stuff. So I guess let's end it. Well, I am Aditya Bacharni and I am an engineer for fun. Bye.